Hello, Namaste. Welcome to Swami Vivekananda GS. If you are preparing for competitive exams like SSC, RRB, and PG Police, you are at the right place. My name is Tarun Kumar. Today we will be discussing a topic called optics. With the help of definition, we will be learning what is optics. It is a branch of physics which deals with the study of light and its interaction with materials is matter. That means it is a branch of physics which deals with the study of light. That means optics is studying how light behaves and etc and how it interacts when it comes with the contact. That means when it light comes contact with the materials, like we can take example materials like metals, or else we can take walls, etc. Now we will be learning what do you mean by light. Light. What is light? Light, it is a form of energy. That means light is a form of energy which creates or produces the sensation of vision, which enables us to see objects. For example, if a person standing in a dark room, we can't able to see. After when we focuses a light on the person, we can able to see. That means it which creates or produces the sensation of sound, sensation of vision. That means when we focus as light on a person standing in a dark room, we can able to see. That is sensation of vision. With the help of light we can we can see with your naked eye, and which able to see our us to see the objects. After this we will be learning how light is classified. Light is classified into three categories. First one is source, second one is visibility, third one is emission. What do you mean by source? In source, it is classified further classified into two types. First one is artificial, or second one is natural. If we take artificial light, that is made by man, that is for example bulb or else lamps, it comes under artificial. Whereas source natural, which is not created by man, that is sun or stars. I will be writing here sun or stars, here bulb, lamps, etc. When we comes to visibility, it is further classified into two types, that is visible light and non-visible light. In non-visible, it is classified into two types, that is UV rays and UV light and infrared rays. UV rays and infrared rays. When it comes to emission, it is also classified into two types, that is luminous and non-luminous. Take a screenshot or a note. I will be waiting for 15 seconds. Now we will be learning in detail what is visible rays, visible light. The light or rays whose wavelength varies between 400 nanometer to 700 nanometer. This is the wavelength where we can see with your naked eyes. The light which varies between 400 nanometers to 700 nanometers wavelength we can able to see. For invisible light, the light or rays whose wavelength is not varies between 400 nanometer to 700 nanometer, we can't able to see with our naked eye. That means in invisible light it is classified into two types, that is UV rays and infrared rays. That means if we see the wavelength of UV rays, it will be varies from less than 400 nanometers. For infrared rays, it is more than 700 nanometers. If in day to day life we are so much habituated to the products uh, which are functions with the help of infrared rays and UV rays. Let me give an example, that is if we take the TV remote, heater, water heater, and in when in 2020 the world is so impacted with the pandemic coronavirus, in which the uh, doctors are used the temperature checking machines which are operated with the help of infrared rays, that is temperature checking machines. When it comes to UV rays, examples are sun's UV rays, we can't able to see. uh, Currency checking machines. UV rays we can't able to see. Currency checking machines is used to know whether it is a, governmented uh, released notes or fake notes. It will be seen with the help of UV rays. Now we will be moving to emission of light. How light is emitted? That is, it is divided into two types: luminous. What do you mean by luminous? Those which those who emits or produces their own light, they are called luminous objects. That is, for example, if we take sun emits its own light. If we take stars also emits their own light. If we, for non luminous objects, those who reflects the light from those who reflects the light of luminous objects, they are known as non luminous objects. Example: moon, planets, walls, etc. If this is the most important point which will be asking in the competitive exams, that the light emitted by the moon, whether it's emitted or it's reflects the light of a luminous object. The answer is the moon reflects the light which is produced or emitted by a luminous object. And the planets, as you know, daily the sun rises, and the sun, when sun rises, the light is being produced, emitted by the sun, by which we can see the objects, or we can walk, or we can do our daily activities properly. Make a note or take screenshot. Now we will be learning about reflection of light. Reflection of light. What is reflection of light? Bouncing back of light rays to same medium after striking the reflector. If we take an example, it is a plain mirror which is coated with silver coating. silver coating, when light is struck on the mirror and it will reflected back to the same medium. That means if we take example, this is xy plane. When light is being impacted or impinges on a mirror and it is being diverted back to the same medium, that is xy plane. It doesn't goes out of the plane, that means other plane like yz plane or zx plane. It is reflected only in one plane, that is same medium. So that is known as reflection of light. How reflection of light will be behave and what are the terms included in reflection of light? Terms included in reflection of light. Firstly, I will be explaining what with the help of diagram, and then I will be writing the definitions or the one liners after explaining the diagram. This is a xy, this is a plane mirror which is coated by silver. Silver coating is being done on a mirror because silver is a good reflector of light. It doesn't absorb, it will reflect back 90 to 95% of the light. So we will be using silver coating. The light is striking the mirror and it is reflected back. This is known as incident ray. Incidence ray. When incident ray impacted or striking on the mirror, where the point first it impact, it is known as point of incidence, and the ray which bounces back, it is known as reflected ray. Reflected ray. The imaginary line is drawn from the point of incidence is known as normal, and the angle between normal and incidence ray is known as incidence angle, that is I. Here I will be writing what is I. It is denoted by a small I called incidence angle. The angle between normal and reflected ray is known as small r, that is reflected angle, reflection angle. The angle between incidence ray and the surface of mirror is known as glancing angle. Glancing angle, that is denoted by a small g. Same here, the angle between reflected ray and surface of the mirror is also known as glancing angle. Take a screenshot or make a note. After this, we will be discussing the one-liners. What is incidence ray? What is reflected ray? incidence ray. The ray of light falls on the mirror is known as incidence ray. Second one is point of incidence. The point where incidence ray falls on the reflector is known as point of incidence. After that, what is reflector? The bouncing back of light ray after striking reflector is known as reflected ray. Normal, an imaginary line drawn from point of incidence which is perpendicular to the reflector, in this case mirror, is known as normal line. Next, reflector, plane mirror, which is coated with silver in order to reflect maximum amount of light is reflector. That means a plane mirror which is used as a reflector which is coated with silver, because in order to reflect maximum amount of light uh, as reflected ray. Copy this or take screenshot. Now we will be discussing what is incidence ray, incidence angle. The angle between incidence ray and normal. This is known as incidence angle. Reflected angle. Reflected angle. The angle between reflected ray and normal cleansing angle. Angle between incidence ray and surface of mirror. After this, we will be discussing about angle of a glancing angle. Glancing angle can be written as G is equals to I plus G is equals to 90 degrees. That is, in the diagram we have known that it is a normal incidence ray falls on this. This is I, this is G. That means I plus G is equals to 90 degrees. This is what I want to explain to you. After this, we will be discussing about diversion of angle. Deviation deviation of ray. Deviation of ray. How a light ray deviates when a reflector has been placed after striking the reflector, how it is deflected from its original path. That means deflector means deviation from its original path after striking the reflector. That means, for example, if a boy is walking in the road on the road, after some time, the boy is being advised to go to right side in order to reduce the time to reaching the destination. That means he is been deflected towards from its original path. He want to move in a straight path because of some suggestions given by the people or anyone. He has taken a shortcut. That is, he is deflected from its original path. For example, this is a mirror, flat mirror. A incidence ray falls on the mirror. This is point of incidence and it is reflected. But if we take a transparent glass, it doesn't absorb, it doesn't reflect. The light will be passes through the transparent glass and it will move in the same path without reflecting. That means this angle is known as angle of deviation. Angle of deviation. This angle, it is denoted by delta. Angle of deviation is denoted by delta. Please copy this. Before heading, I want to share an important rules, that is loss of reflection. What is loss of reflection? Loss of reflection. First point is the incidence ray, the reflected ray and the normal should be lie in a same plane at point of incidence. That means incidence ray, reflected ray and normal should lie in a same plane at point of incidence. These three should lie in a same plane. It should not be reflected or diverted to other plane. Second point is angle of incidence is equal to angle of reflection. That is, angle I should be equals to angle R. This is the most important points you should remember in order to remember for a long time. Now we will be discussing how angle of deflection will be. If we take a plane mirror, when an incidence ray strikes on the mirror at point of incidence, it will reflected back, but its original position is path is like this. The angle, the difference between the angle between the reflected ray and original path of the ray is known as angle of deflection. In previously we have discussed the angle of deflection is denoted with a delta. This is reflected ray, this is incidence ray, this is glazing angle, this is normal, this is incidence angle, this is reflected angle. From this diagram we will be, the examiner will ask some questions, that is what is deflection angle. If we want to solve the problems from this, we have to know the relations, how we can get deflection angle, how we will be getting glazing angle, incidence angle and reflection angle. Please copy this, we will be discussing after copying this. I will be not dropping this. I will be discussing here because with the help of diagram you can remember very easily. From this diagram we can write I angle of incidence plus angle of reflection plus angle of deviation is equals to 180 degrees. This is 180 degrees. As from laws of reflections, we know that angle of incidence is equals to angle of reflections. Where I is there, we will be substituting R. Where R is there, we will be substituting as I. That means I plus R can be written in terms of I plus delta is equals to 180 degrees. This is equal to 2i plus delta is equals to 180 degrees. Delta can be written as 180 minus 2i. If the examiner asked delta in terms of incidence angle, this is the answer. If we ask in terms of glazing angle, then I plus G is equals to 90 degrees. If we want glazing angle, 90 minus I, G is equals to 90 minus I. Here delta is equals to 180 minus I can be written as 90 minus G. 90 2 into I can be written as 90 minus G. That means delta is written as 80 180 minus 2, 92 ja 180, minus into minus plus equal to 2G, plus 180 minus 180 will be cancelled, and the delta can be written as 2G. If we ask in the terms of glazing angle, we have to use this formula, that is delta is equals to 2G. If we ask in the terms of incidence angle, we have to use this. This is important formula for students preparing for board exams. It is very important relation, you have to remember and we have to practice. If you are preparing for just competitive exams, we have to remember this relation. It is more than enough. I have recovered some PYQs based on this topic. I will be writing question and solving that. Question is, if a ray of light is incident on a plane mirror at an angle 12 degrees with the mirror surface, find angle of reflection small r, glazing angle small g, and delta. If a ray of light is incident on a plane mirror at an angle of 12 degrees with the mirror surface, that means if it is a mirror, it is an incidence ray, reflected ray, it's a normal, it is the incidence angle, it is reflection angle, this is glazing angle, this is glazing angle, and this is deflection angle. Small r, small I, G, G. From this, he is asking that incidence on a plane mirror, this is a plane mirror at an angle of 12 degrees with the mirror surface. That means, as we know, the angle between incidence ray and the surface of the mirror is known as glazing angle. That means he gave a 12 degrees with the mirror surface. That means he gave glazing angle. That is, this is 12 degrees. That means this is 12 degrees. This glazing angle will also become 12 degrees. That means it is a supplementary angle, that is 180 degrees. 180 degrees minus 2 glazing angle, that is 24 degrees. If we subtract 180 minus 24, then we will be getting 156 degrees. That means incidence angle plus reflected angle will resulted as 156 degrees. That means I is equals to 78 degrees, R is equals to 78 degrees. That means we know I, R, G. Previously we have solved some relation. From that we have got the results at delta is equals to 180 minus 2I, and in terms of G we got the result as 2. We got result G is equals to 2, delta is equals to 2G. This is the relation we got. If we use this relation or this relation, we will be getting the same answer. I will be solving in both using both relations. 180 minus the incidence angle is 78 degrees, that is 2 into 158, 2 into 78, that is 156. 180 minus 156, the delta is 24 degrees. If you use this, 2 into glazing angle, that is 12 degrees, delta is equal to 24 degrees. If you use any of the formula, we will be getting the same answer, that is 24 degrees and the 24 degrees. From this, delta is 24 degrees. This is the important, this is so important. You have to remember the formula relations, and we have to just substitute the relations in the given data. But you have to know what is glazing angle, what is incidence angle, what is reflected angle, and what is angle of deviation. Please copy this form problem. Let's explain the another problem also to understand in better way. The another problem is, if the ray of light is incident on a plane mirror at an angle of 15 degrees, at an angle of incidence 15 degrees, okay, at an angle of incidence 15 degrees, incidence 15 degrees, find the angle, find the find the angle of reflection. The same question, but you have to check whether it is asking glazing, whether he is given glazing or incidence or reflected ray. Here he is mentioned that the light ray is making an angle of incidence of 15 degrees. Before this problem, it is making an angle of 12 degrees with glazing angle, that is glazing angle 12 degrees. Here 15 degrees incidence angle. That means if we take a plane mirror, incidence ray, normal, reflected ray, glazing angle, incidence angle, reflected angle, and deviation angle. Here he is mentioning 15 degrees, that is this is 15 degrees. As we know, angle of incidence is equals to angle of reflection. If it is 15 degrees, it will be also 15 degrees. 15 plus 15, 30 degrees. I plus R is equals to 30 degrees. Out of 180, if we eliminate 30 degrees, the remaining will be 150 degrees. That is glancing angle is, we got glancing angle as 150 degrees. Here we have two glancing angles. If we want only one glancing angle, 150 divided by 2, that is G is equals to 75 degrees. From the second relation, that is delta is equals to 2G. From these relations, delta is equals to 2 into 75, that is 150 degrees. Angle of deviation is 150 degrees. Lensing angle is 75 degrees. Incidence angle is 30 degrees, 15 degrees. And reflected angle is 15 degrees. I is 15 degrees, R is 15 degrees, G is 150 degrees, 75 degrees, and delta is 150 degrees. Please copy. Okay friends, today we will be ending this session, and rest of the topic will be discussed in the next session. And before ending the video, I want to end with a quote which is inspired by Swami Vivekananda, that is, arise, awake, and stop not till the goal you reached. Thank you. If you like my video, please share with your friends and others. Please subscribe Swami Vivekananda GS. Thank you.